Good afternoon, students.
Good afternoon, ma'am.
In the last lecture, we revised chapter 3, correct?
Yes, ma'am.
Yes, ma'am.
Any doubt till
Yes,
chapter
ma'am.
3?
Yes, ma'am. That algorithm part one.
Yes?
Algorithm part I have doubt, ma'am.
Algorithm part, okay.
Yes, ma'am.
Yes, ma'am. I have
And the encryption and decryption.
Encryption and decryption, okay. Anything else?
Ma'am, algorithm.
Contour one
Ma'am,
function.
so many doubts are there. Ma'am, I have also one doubt in chapter one, that last bit, ma'am. Again, I got confused.
Okay, let's today clear your doubt only.
Okay, ma'am.
Yes, ma'am.
Yeah, here I have space. Yeah, tell me. From chapter 1.
Yes, ma'am.
A particular question, tell me.
Ma'am, in chapter one, last one, ma'am, the rule of that information was there, no, ma'am? That part, ma'am.
तो क्वेश्चन तो होगा कोई
Question, ma'am, that topic one, ma'am. I'm not getting.
that topic, okay.
Yes, ma'am.
Yeah.
Yes, ma'am.
These rules.
Yes, ma'am.
So I'll just revise these rules and then tell me which particular question you heard out, okay? So rule of inference used to conclude the conclusion from the given statements, okay? Or sometimes it will be conclusion also given and those hypothesis also given. You need to just give the rule of inference. Which rule of inference used to find that conclusion from the premises, from the hypothesis, okay?
Yes, ma'am.
For example, the hypothesis is P. This is given hypothesis, and P implies Q. From here, you can conclude Q. Okay, these should be same, right?
Yes, ma'am.
You have something implies something, and this first should be match. Okay, then you can conclude Q from these two statements.
If ma'am, I doubt, ma'am. In if hypothesis will be given, then premises is conditional to a conclusion. That conclusion part will be the final one.
Conclusion part is the final one.
Yes, ma'am.
After therefore, whatever the this therefore, after therefore whatever statement, that is your conclusion.
Yes, ma'am.
Okay. Everything else is premises, yeah, or you can just say hypothesis. Clear?
Yes, ma'am.
So modus ponens, by using modus ponens, if you have P and P implies Q, from here you can conclude this Q part. Okay. For example, suppose I'm just taking one example that if today is Monday, then there is a quiz. Okay, this is P implies Q, right? One statement I'm making this one. If today is Monday, then there is a quiz. And second statement I'm giving you, today is Monday. Then what you can conclude? There will be a quiz, obviously, right?
Yes, ma'am. Yes, ma'am.
So that rule name is, this conclusion is coming from these two statements. This rule is known as MP, modus ponens. Clear?
Yes, ma'am.
Okay. Next is you have P implies Q. That is, if today is Monday, then there is a quiz. You have this one. And second statement I am making, that negation of this part. Okay. Something implies this thing and negation of this thing, right?
Yes, ma'am.
Okay. These will be negation of each other. That is, if for our example is, if today is Monday, then there is a quiz. Okay. That means, and second I am just making there is no quiz. Means what? Today is not Monday, right? That's what you can conclude. Clear?
Yes, sir.
Okay. So negation P you can conclude. That is, if you have P implies Q and negation of this one, then you can conclude negation of this hypothesis P implies Q. In this one, negation of P. Then this is known as modus tollens. Okay? Clear?
Yes, ma'am. Yes, ma'am.
Okay. Next is HS,
Ma'am.
hypothetic. Yeah.
Ma'am, that negation part is there, ma'am, in Q, ma'am. That one, ma'am, once more, can you explain, ma'am, that negation part one, ma'am?
Okay. See, with the help of example only, I'm just giving you. If there is a quiz is P, okay. Sorry, if today is Monday is P, then there is a quiz is Q, right? Today is Monday is P, Q is there is a quiz, okay. So if
Yes,
then is P implies Q. Understood? And
Yes,
the
ma'am.
second statement, we are saying that there is no quiz.
Yes, ma'am. Yes, ma'am.
Okay. Then you can conclude from here that today is not Monday. That's why there is no quiz, na?
Yes, ma'am. Therefore, will be then negation of the P. If therefore, if there is not quiz, then therefore it is not Monday.
Yes.
Okay, ma'am.
This is your modus tollens. It could
Yes,
be like you have Q, P implies negation Q. Then also you can conclude negation P, right? You have
Yes, ma'am.
negation of these each other, then negation of this one you can conclude, okay?
Yes, ma'am.
Similarly, if you have negation P implies negation Q, then negation of negation P, this will be only P.
Okay, ma'am.
Okay.
Yes, ma'am.
So anything equivalent to this type, that will be, that is P implies Q and negation of this thing, then you can conclude negation of first thing. Okay.
Yes, ma'am.
This is hypothetical syllogism. HS. HS says that P implies Q and this is same. Q implies R. Okay. P implies Q, Q implies R. These matches. Okay. This Q. Then you
Yes,
can
ma'am.
conclude P implies
R.
R. Okay. This is same as saying P implies Q and next you have Q implies R. So obviously P implies R.
I mean,
Clear?
both the statements should be interrelated to each other.
Yes.
Okay.
This Q should be same.
Yes, ma'am.
Okay. The second part
Yes, ma'am.
should
Yes,
be same. That is conclusion for first one and hypothesis for second one should be same. Then you can just say P implies and yeah,
R.
both
Yes,
should
ma'am.
be implication.
Yes, ma'am.
Okay, if then you can conclude P implies R. Okay.
Yes, ma'am.
Next is DS, disjunctive syllogism. This is you have disjunction of P and Q. Okay, disjunction of P with Q.
With Q.
Negation of this one, either this one or this one. It could be disjunction of PQ and negation of Q may be there. Okay.
Yes, ma'am.
Then you can conclude negation of Q and Q cannot exist together in this one. So P you can conclude. Okay. And in this one, negation of P and P cannot exist together. That's why Q you can conclude. Okay.
I didn't get you.
You are just saying here either P is true or Q is true. And in this next statement, you are saying P is not true. Then conclusion is what? Q is true. Clear?
Got it, ma'am.
Got
Yes,
it?
ma'am.
And here, if you are saying either P is true or Q is true, then next statement you are making Q is not true. Then what should be the case? P is true.
Ma'am, mean the outcome will come based upon the premise and the conclusion. Whatever the negation will be there, down to the statement, then therefore, based on that, we will find out the therefore statement.
Yes, yes,
Okay,
yes.
ma'am.
The thing is, if your one statement is there and the negation of that statement, these can't be true at a time, right? Simultaneously, they can't be true. That's why you need to discard these.
Yes, ma'am.
Okay, you can have the other one as conclusion. So that is DS. Okay. One more thing, that is this one is resolution. Okay, this one type of disjunctive syllogism only, but here what you have in resolution, you have disjunction of two statements. Okay, P disjunction Q and negation of either of this one. So if you have negation of P disjunction with some other statement, then you can conclude P and this negation of P can't exist together. That's why disjunction of these you can conclude Q disjunction R. Okay, or what you can have P disjunction Q, negation of this one, disjunction with some other statement. Then Q and negation Q can't exist together, right? Then you can conclude P disjunction R. Got it?
Yes, ma'am.
Yes,
So this
ma'am.
is your resolution. Don't get confused with this DS and resolution, okay? In resolution, you have both premises with disjunction part, okay?
Yes, ma'am.
But in DS, you have one and one with negation. Yeah. Next is addition. You are given one statement. You can add any other statement, whatever you want. Okay, whatever you need. But with the sign, with the operation with disjunction. Okay. So with P, you can add P disjunction Q. Okay. Or if you need P disjunction R, then you can have that conclusion. This is your addition. Addition is only possible if you are using disjunction. Okay. Don't try to use conjunction here. Clear?
Yes, ma'am.
Because disjunction will depend on the truth value. Truth value of this disjunction will depend on the truth value of P only, right? If P is true, then this statement is true, this total statement, right? Okay.
Yes, ma'am.
Yes, ma'am.
Yeah. Then you have simplification. In simplification, from the conjunction P and Q you have, you can, if you want P, if you want to conclude P, or if you want to conclude Q, you can conclude because you have P conjunction with Q. That means both statement you have, right? From here, whatever you need, you can conclude it. If you need Q, then you can conclude Q, right? If you need P, you can conclude P. Clear? From the conjunction, that is P and Q you have. That's why you have both statement, P as well as Q. Understood?
Yes, ma'am.
Next, conjunction. If you have two statements, then you can say you have P and Q, right? From here, you can conclude P and Q. Okay? P and Q by taking conjunction. Okay. So these are rule of inference. Any particular doubt? Here you need to just use the rule of inference. That is, tell which rule is the basis of the following argument. Argument is given as It is below freezing now. Therefore, after this one, you have conclusion. Okay. Therefore, it is either below freezing or raining now. So you can translate into logic. It is below freezing now. You can just take this as P. Therefore means conclusion, right? So it is either below freezing. So either or means it will be disjunction. So P disjunction raining now. So it is raining now. You can just take as Q. So from P you can conclude this. So which rule?
Addition.
Addition, right?
Yes, ma'am.
And here it is below freezing and raining now. Therefore it is below freezing now. This means from P and Q, you just try to
Simplification.
conclude P. That is simplification. Okay.
Yes, ma'am.
Here, if it rains today, if that is P implies Q, Q implies some R. Okay. Then this is saying therefore P implies R. It will
Yes,
be HS. Okay. So if
yes,
it rains today, you have taken as P. We will not have a barbecue today. That is Q or negation Q. If you are taking, we will have barbecue today. Then it will be negation Q, right? So first statement is P implies negation Q. Then if we don't have a barbecue today, then we'll have it tomorrow. Okay. So next statement is negation Q implies Q. Okay, from here also you have this negation Q and negation Q same. So P implies Q, right? So this rule is which rule? HS, right? Clear? Don't get confused between this one.
Yes,
P implies some statement. The same statement implies some other statement. So P implies conclusion. After in the conclusion, what we have? P and this one is Q. So P implies Q. Understood?
Yes, ma'am.
Then try to do this question. Try to solve it. Here, these are up to this one. These are hypotheses or premises, and this one is your conclusion. Only if, yeah, that you can assume. Okay. So just translate it into logical expression.
First we'll write that negation P disjunction R.
Yeah, if you are just taking
If it is not sunny, then
this
we'll
after
write
plus P, so it will be negation P, right?
yes, ma'am.
So negation P, then
Conjunction
conjunction.
R, I think so.
It is colder than yesterday, you assume.
Okay, yes, ma'am. It is colder than yesterday.
Okay. We will go swimming only if it is sunny. Okay, it is sunny, you have just taken as P, right? So what about this one? This you can consider as some R. P you have assumed Q. So R will be, we will go swimming, right? Yeah. What should be the statement according to this? If you are considering this as R, this you have P. Second statement. This was your first premise. Second
Negation of
premise.
P.
Yes.
Negation of P.
Negation of P. We will go swimming only if it is sunny.
No.
Which format is this? Conditional, no?
Yes, ma'am. Ma'am,
conditional-
R to P, ma'am. R to P.
R implies P, right?
Yes, ma'am. We'll
There
go
is,
for swimming if it is
This
sunny.
only if This is in case of P implies Q, it will be only if will be applied with Q, right? So otherwise, if whenever all these are applied with the first one, right? It is
Yes,
R
ma'am.
implies P. What about this one? This is negation R. Then we'll take a Kennewick strip. This you can just take as R T. Okay. Third is negation R implies. Yes, please
Yes,
respond.
yes, yes.
Okay, S you want to take? Okay, I can take S. So this we have taken as S, right? If we take a conventional S, will be home by sunset, right?
Yes, ma'am.
This is your T. Conclusion is again T. You need to show that these all premises. Yeah, first let me finish this.
Yes, ma'am.
S
S
implies T.
implies T.
Yeah, you need to show these premises concludes T.
T. Yes.
By using rule of inference, you can conclude it. So, which statement by using you can take any of these statements. In fact, all of
Ma'am.
these statements you need to use.
Ma'am, HS on 3 and 4.
3 and 4. So yes, HS on 3 and 4. You can have the conclusion as conclusion will be
Negation R implies T.
T. Here you can just write HS on line number 3 and 4, right? Then
Ma'am, then
simplification on 1. So negation P, right?
Yes, ma'am.
See here we don't need Q, that's why we are not simplifying Q, okay? 1.
Yes, ma'am.
Simplification on 1. 7. Modest tolerance on which? 2 and
2 and 3.
2 and 6. For modest tolerance, you need 2 statements, na? 2 premises. 2 and 6. What do you got? Negation R. Good. Then being used. Modest exponents on 5 and 7 to get T, and that's what your conclusion, right? Any doubt? These are premises, given premises.
Ma'am, the complete last part, premise part.
From
Complete premise part, ma'am. That last part, solving for the therefore, I mean conclusion part for that.
see, conclusion is already given, premises are given, right? So first
Yes, ma'am.
what you do,
Then-
you convert into logical expression. Okay, we have converted premises into this one, right?
Yes, ma'am.
Yes,
So
ma'am.
from
Yes, ma'am.
these premises, we want to conclude as T. T is our conclusion. Okay. So our focus is
Okay,
to
ma'am.
get T.
Yes, ma'am.
Clear? By using rule of inference. You can use 1 rule, 2 rule, or whatever you need to conclude T. Okay. So what we have done is we have applied HS on 3 and 4. Why HS? Because at 3 you have implication, and second thing is same, right?
Yes, ma'am. Yes, ma'am. Then it will be R is implies to T. Yes, ma'am. Negation of
Right?
Yes, yes,
That
yes.
R implies T. So somehow if I get negation R, then T will be conclusion by using modest exponents, right? So
Yes, ma'am.
now negation R is where? Here, but we have used this, right? And anything else? Here we have, right? Negation R we need, but here we have R. So
Ma'am, we
negation
can
R,
write
how to get
contrapositive. Contrapositive
contrapositive you can
statement.
take. Yeah,
Yes, ma'am.
contrapositive,
Negation
you
P
can just
implies
write the
negation R.
equivalent statement, negation P implies negation R, right?
Yes,
You
ma'am.
can write that.
Yes,
Then
yes,
you
Ma'am,
need to
then
write
we can apply, ma'am,
contrapositive of
HS on.
second, this one. Then
1 and 6 also we can do, ma'am, negation of P and negation of P, then the outcome will be there for statement Q, ma'am.
1 and 6.
Yes, ma'am.
So 6 is the conclusion of 1, na?
Sorry, yes, ma'am.
Simplification, we are just
Yes, ma'am, yes,
applying
ma'am.
simplification on this one to get negation P. Okay. Now
Sure.
negation P and second. What
Yes,
you can
ma'am.
do? By using, if you are writing a contrapositive, then by using modus ponens. Otherwise, if you don't want to write this one, then you have R implies P and a negation of P, right? Then what you conclude? Negation of
R.
R. Correct?
Yes, ma'am.
By
Yes,
using
ma'am.
modus tollens. And negation R you got, that's what you wanted for this statement, right? To get T. So,
Get T, ma'am.
modus ponens are 7 and 5 to get T. And that's what conclusion is. Any doubt?
No, ma'am.
So now you can solve.
Yes, ma'am.
Yes, ma'am.
Ma'am, another doubt in that predicate and quantifiers one, ma'am, one question was there, ma'am.
Yes, tell me.
Ma'am, exercise 1.12, ma'am. That question number option D, D bit, ma'am.
1.12. Tell me the question. I don't know.
Okay, ma'am.
Ma'am, I have also doubt. Ma'am, can I see?
Hmm?
Ma'am, where to use nevertheless word?
Nevertheless,
Yes, ma'am.
I think in P implies Q you can use unless or nevertheless. In case of P implies Q. So let me check. I'm not sure whether you are able
Ma'am,
to.
one question is there. That's why
Yeah.
I'm asking.
Nevertheless, there is no question. Either you are getting wrong question.
No, ma'am. Book
Ah,
name.
it
Yes,
is in
ma'am.
the book. Yeah.
Yes, ma'am.
Okay, tell me. What is that? Yeah.
Ma'am, question.
P implies Q. For P implies Q, you can use Q unless P. Unless negation P.
Yes, ma'am.
Okay? Q unless negation P. Actually, all other are included in this PDF, but this was left. Yeah, any other doubt? Yeah, what you were talking about? 1.22, which
1.12,
D?
ma'am. Ma'am,
1, 2.
P of X is given that X is your friend.
Hmm.
Ma'am, 1 second, ma'am. Let me open the question.
P of X is given as X is your friend. Okay, that is perfect and that friend, right?
Yes, ma'am. Yes, ma'am. That question.
Yes, bit D. Okay, let me go to that only. Yeah, this one.
Yes, ma'am. Ma'am, D bit, ma'am. Ma'am, how that conjunction came, ma'am, and, ma'am, but that one, ma'am, D. Yes, ma'am.
Whenever you are using, if you don't even understand till now, whenever you use there exists, always use conjunction. Okay,
Okay, ma'am.
that means you are not talking about universally. Okay, you're not talking about all of your friends. So
Yes, ma'am.
means at least one of you are talking about this property about
Yes, ma'am. Yes, ma'am. One, particularly one.
Some
Yes, ma'am.
at least one, right? So
Yes,
that's
ma'am.
why you need to specify and with and.
And
Okay.
okay, ma'am.
And whenever you are talking about all, then this implies will be perfect choice. Okay. That means this is implies is obviously used
Can you again tell the
because if you take any x and that is perfect, any friend,
Ma'am, here
any
also we
x.
can use the conditional also we can use, no, I mean statement D.
No, you can't use because you're not talking about universally now. If you are suppose A is at least one, A and B. You are talking about only these one. These are perfect. Okay.
Okay, ma'am. Okay, ma'am.
And in domain there are many other. Okay. There is C,
Yes,
there
ma'am.
is D. So what about if you are saying that at least one of your friend is perfect? So means to say you are saying about this domain that you can take any
I mean
at least
anyone.
one, okay,
At least one.
anyone, and that
Yes,
will
ma'am.
be perfect. So that is
Okay, ma'am. Okay.
wrong perception, right?
Okay, ma'am. I mean, whenever we'll use the existential quantifier, then
Yeah.
we have to use the conjunction one.
Yes, yes.
Okay, ma'am.
Always this one. For all is with this
Ma'am,
one and
ma'am, but
conjunction
in
with.
disjunction case, in existential quantifier, in disjunction case, already or will be given in the statement, ma'am. But while using the conjunction one, but here and is not given, ma'am. How can we identify that it's Ma'am, in some cases, disjunction one particularly we can find out that it's a disjunction case, or will
Then
be
you
mentioned.
whatever it is for all or there exists that
Yes, ma'am.
means if explicitly it is writing or and then you need to obviously
Okay, ma'am. Okay, ma'am. Yes,
explicitly
ma'am.
use this
Yes,
one
ma'am.
and this
Got
one.
it. Got it. Yes, ma'am.
Got it?
Yes, ma'am.
Anything else from
No,
chapter
ma'am.
1?
Algorithm.
Yeah, chapter 1.
Algorithm.
Chapter 1.
Chapter 3.
Ma'am, wait a second.
I am asking about chapter 1. You are saying
Chapter 1
3.
cleared, ma'am. All.
Done.
Yes, ma'am.
Okay,
Ma'am,
chapter
ma'am,
2.
excuse me, ma'am.
Ma'am, how to represent, ma'am, exactly two persons?
Excuse me, ma'am.
Yeah.
Ma'am, in the topic nested quantifiers, ma'am, there is a question in example 1.17. Ma'am,
Yeah.
it is asking.
Yeah.
Yes, ma'am. Ma'am, in that in the last line, ma'am, where we have to mention for the third person. We are
Yes.
going for X, who is a friend of means Y can be only friend of X, ma'am. But what is the need of Z? Like the
What
third person.
is the need of Z? Means here you are just saying at least one. There exists Y means what? You are talking about
Ma'am, we will
some
take
friend.
Y as a friend of X. So is that any need of mentioning Z over there?
If you don't want to mention this Z, then use this for all X. There exists exactly one. For exactly one, there exists unique. You can use there exists and then exclamation sign, this operator Y. Then no need to mention this Z. Okay? No need to mention this
Can you
statement.
again tell about the exclamation mark, ma'am? What is that? I don't know.
Actually, for unique, there is unique. There exists unique. Okay? There is one and only one. Exactly one. Okay? For exactly one.
Okay, ma'am.
Whenever you are talking about one and only one, exactly one, this there exists unique. This symbol is used. Okay? There exists unique.
Okay,
Okay?
ma'am.
This is uniqueness quantifier.
Okay, ma'am.
Ma'am, I have also got one doubt in that that part, ma'am. Ma'am, if mean suppose in this one we will be using both universal and existential based upon the statement, ma'am. How it will be given. If ma'am both conjunction will be in this particular case we are using, as you said, that if we use existential, then we have to use the conjunction statement. Okay, ma'am. If ma'am a question is coming which contains both universal statement and conjunction statement, and
Hmm.
disjunction is there, which is connecting both the statement. Okay, ma'am. In that cases, ma'am, any conjunction is needed or not needed while expressing for the second, conclusion part.
I think no need.
Okay, ma'am.
So which particular question you are talking about? For
No, ma'am, I was
example,
asking, ma'am, just like this, ma'am. As you said that in existential quantifier, we have to use conjunction whenever it will
okay.
be given. I was
Okay.
asking.
If explicitly it is just asked that here in this statement you are using there
Okay, ma'am.
exist and you are means at least one of your friend is perfect, something like that.
Yes, ma'am. Yes, ma'am.
Or is there, then you can use disjunction. So explicitly you can write that
Yes, ma'am.
disjunction. Then you can use for all or whatever it is given. Okay. Then here
Okay,
you can
got it.
use implies. Okay.
Yes, ma'am.
So I hope you got it.
হ্যালো
Yes, ma'am.
কলটা কেন বল বুঝে পারনু ক্লাস চলছে টি
Who is there? Okay. Now here, what I was telling you, either you can use for all x, there exists unique y such that bxy. Okay, either this one or here you are just saying everyone has some friend, na, at least one friend. This is talking about at least one. At least one is not saying exactly one, right? So you need to exclude all other, right? You need to exclude all other. That is, for all x, there exists y such that bxy. And for all z, which are not equal to y, that are not a friend of x. Okay? Clear? That is, all those person you are talking about, which are different from y, that does not have friendship with x. This means x, that is everyone, has exactly one best friend. Okay? Any doubt in chapter 2? Yeah. A union B? A union B is subset of A. A union B is subset of A minus what is it? A union B minus A. It is not the subset of A union B. It is not always true. Okay. Yeah. Then it is. How? You take some x from here and A union B means x belongs to A. Disjunction x belongs to B, right? And here, this one, you can say you want to show x belongs to A. Disjunction with x belongs to B, but that is conjunction with x not belong to A. Okay. So from here, you want to show B x belongs to A. Disjunction with x belongs to B. Conjunction x does not belong to A. Right? Clear? So can you add one thing over here? That is x does not belong to A. Can you add it? Or you can left hand side or right hand side, you can just say it. How? How? If you apply over here, if you open this one, what is the conclusion? That means what you get in last, x belongs to A, by using distributive law, right? on the left side, but yeah, you need to show from here to here, but you just try to solve whether you are getting this thing or not. Okay, then you can go from bottom to top, right? Finally, you need this one, right? Okay, this one you need. So what I am going to do, you will get it over here only. Okay, we will add something. How we will add? That is x belongs to A, disjunction with x belongs to B. Then conjunction x belongs to A, disjunction with x belongs to x does not belong to A. Okay, this means what? Null set, right? Phi set, or this is you can just say in logic format, this is false statement, right? Right? False or true? Actually, this is true. Disjunction is there, no? So this is true. Okay. So can I add this true statement with the statement, that is P with true with conjunction? Can I add it? Any statement conjunction with true, I can add it because this is equivalent to P. Why? Why? This is identity, right? Right. Or you can just have, because this truth value will depend on P only, right? Because conjunction, if this gives you false, in that sense it will give you false, right? If this is true, means the truth value of P conjunction T will depend on only P, right? Okay, you can take it. P with true. Okay, P is true false, right? If true and true gives you true, false and true gives you false, right? Both are same, right? So equivalent. So can I add this true? Right? So this is according to this identity, that is any statement conjunction with true I can add, that is conjunction with this true statement. And what is this true statement? Tautology. Okay, conjunction with tautology I'm just saying. So that you can take this one. Okay, okay, from here to here and here to here. Understood? How I am getting? Okay. From here to here, this one x belongs to A, disjunction x belongs to B, this one. And tautology means what? I gave you this one, right? Because I needed this. Okay, from here to here. Okay, I hope you got it now. Anything else from chapter? X to the power 5, right? This is 5 plus 1. Okay, you want to check whether it is 1 1 or 1 1 on 2 or not, right? So first, the definition of 1 1 is by using two definitions, that is either you can take different elements and show that their images are different. Okay, or you can just take images same, right? That is contrapositive of the above. This implies elements are same. Clear? So either you can pick this one or you can pick this. Okay, so what do? You can take any two elements A and B, let A and B belongs to domain set such that both are different. Okay, clear? Arbitrary element you have taken. So if both are different, then their height power will be also different. If A and B are not equal, then taking 5 power on both sides, that will be also not equal, right? If 2 is not equal to 3, if I take 5 power on both sides, that will be also not equal, right? add 1 on both sides, still it is not equal, right? So what I got? F of A not equal to, it is 1 1. That is, these two elements are arbitrary. That's why this is happening for all A and B, right? So that's why this is 1 1. How to show this is onto? Yeah, first you tell me what is the codomain for this one, where this is defined, R to R, Z to Z, or where? R to R, okay.
R to R.
This is defined from R to R, okay. So for codomain, that is for onto, all the elements from codomain should have some premise. In that sense only codomain will be equal to range, right? Okay, so take some element from this codomain Y. Okay, Y belongs to R, and this R is what? Codomain. Okay, so let Y belongs to R. For this one, does there exist? That is for all this, for all Y belongs to R, that is codomain, there should exist some X. What is that X? We will find out, such that Fx is equal to Y, right? And what is Fx given? Put the value x to the power 5 plus 1 is equal to Y. From here, what is the value of x in terms of Y? X to the power 5, fifth root. So fifth root exists for all the real numbers. See, Y is real number, Y minus is, 1 is real number. Fifth root exists, right? Third root, odd root exists always, whether it is positive, negative, or 0, right? Odd root exists always. But in case of that square root or fourth root, that is even root, may not exist, okay? That may be, all the roots may be complex, may not be real. But whenever odd, at least one root will be always real, right? So we have this as a real number. So obviously, this is real number, means this belongs to domain. X is where? So x, you can just take this one, Y minus 1. So for this Y, we have this belong to domain. Okay, this is your domain. Okay, so for every Y belongs to codomain, there exists X, and what is that? Fifth root of Y minus 1. If we have Y, so we can also get fifth root of Y minus 1, right? That is working at its premise, such that Fx is equal to 1. Understood? And in case of inverse also, if this is 1 1 on to both, then inverse also, this X will be working as F inverse Y, right? Okay, Fx is equal to Y means to say F inverse Y is equal to X, right? So whatever the value of X, that is coming as F inverse Y, means to say this is giving you F inverse Y as well, right? Now understood? Anything else? Bit string are just this string of 0 or 1. Okay, string that contains 0 or 1. Yeah. That is a null bit string that contains nothing. That is void. It can have any length. Any length. With length 0, it is null. Any other doubt from chapter? So from set theory, then function, then it's summation and sequence and summation. Any doubt? Yeah, algorithm. Who had doubt in algorithm? Yes, algorithm.
Ma'am, ma'am, I had
Yes.
doubt.
Yes.
And my friends.
Tell me.
Ma'am, I had doubt.
हाँ तो बोलो तो डाउट क्या है?
मतलब लेक्चर 1.5 होल
Lecture 1.5 15, this one.
लेक्चर 15, yes ma'am.
Okay, see, in algorithm we did the searching algorithm and sorting algorithm. Okay,
Yes.
so in case of searching, we had linear search and binary search. So what we do in searching, we are given one element, we want to search that we name as x, we want to search for x in the given list. Okay, both are given, x is given and list is given. This list will be having distinct integers. Okay,
Yes ma'am.
and what is the procedure for linear search? What you do, just line by line, that is one by one, linearly you check it whether it is equal or equal to the first element, start with first element, whether x is equal to first element or not. If it is equal to first element, it give you the location of first one. In searching, what we want, location of the x in the given list. Okay,
Yes
we are
ma'am.
searching for location. So if x is equal to a1, then it gives you one location. Okay, if it is not equal to a1, then it goes to second. Okay, it checks whether
Yes ma'am.
it is equal to a2 or not. If yes, it gives you location 2, otherwise go to second one, right? Third,
Yes ma'am.
and so on, right? So this is the code
Hello.
that I is it starts with I is equal to 1, while
ठीक है रहूं ना.
I is less than equal
Yes
to
ma'am.
n.
Sorry ma'am. Sorry.
I is less than equal to n, that means we are in the list or not. We can go up to n only, right? So we are in the list or not. Yes, if whenever we are in the list, and it checks whether it is not equal to ai. Okay, whenever it is not equal to ai and this is satisfied, that means we go for checking to the next element. I become next. Okay, initially it was 1, that is 1 is less than equal to n, and x is not equal to a1, then I become 2. Then again check 2 is less than equal to n, and
N.
x is not equal to a2. If it is true, so this keeps going, this keeps running until this become false, right?
Yes ma'am.
So this is true, 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 it will keeps changing, right?
Yes ma'am.
So once it is false, once this condition is false, either this one or this one, because there is n, right? Then it comes to if else. Okay, so if I is less than equal to n, again it checks whether you are in the list or not, then it gives you location, otherwise it will give you 0. Here 0 means x is not present in the list. Okay, it will return you whatever the if it is I, so return you the location. Okay,
Okay
if
ma'am.
it is present in the list, it will give you location of that element which is equal to the x, otherwise it will give you 0. Okay,
Yes ma'am. Yes ma'am. Hello. पढ़ेगा. Hello.
yes. Now you want to search for 7 in the list. Okay, so this is your a1, a2, a3, a4, a5, a6, a7, a8. So this is present at a6. So according to this algorithm also, it should be equal to 6. Location it should give as I na, that means location of this element it should be, right?
Yes ma'am.
So it starts with here we got as x as 7, and these are AIs, and n is 8, right? N is 8. So first is it starts with I is equal to 1. So it checks whether while 1 is less than equal to 8 and x is not equal to a1, that is
A1.
7 is not equal to 1, right? It
Yes
checks
ma'am.
it is not true. This is true and true. This means true. So I become 2.
Yes.
Okay. For
Yes
second,
ma'am.
2 is less than equal to 8. X is not equal to a2. That means 7 is not equal to 2. This is true. So I become 3. Like this,
3.
up to this one, it will be true, true, true. Right?
Yes ma'am. True.
Up to this position, that is x equal to a6. Here, up to a5, it is true. So this I become now 6. Then in case of 6, again it goes to here. 6 is less than equal to 8, and x is not equal to a6. That is 7 is not equal to 7. This means 7 is not equal to 7. So what do you got? This is false, right?
Yes, ma'am.
False and something false, right? So now it exit. This will not run, right? It exits
Yes, ma'am.
while loop, right? So
Yes, ma'am.
outside it goes to if else, right? So if I, what we have 6 now, till now we had I is 6. So 6 is less than equal to 8.
8.
Again check this condition. Yes, true. So it will
Yes,
give
ma'am.
you location as 6. Okay, return location 6. If it would be not true, that is, suppose we have checked for all element up to n, we don't get this element. So in that case, x is equal to an at last, not equal to an, that will be also true, right? This is true and this is true. Clear? Means I become n plus 1. Because all of this one, x is not present in the list, then all these will give you true, true, true. I become n plus 1. Then again it goes for this condition, that is n plus 1 is less than equal to n. Is this true?
N plus 1 is not equal to n.
This one, n plus, I become, see, it will check a1, a2 up to an. Everything is true. Because x is not equal to any of this one. So I become I plus 1, that is n plus 1 after nth
Yes, ma'am.
step. So again it will check for this one, that is n plus 1 is less than equal to n. Is it true? False.
False, ma'am.
Right? False and something false. Right? Anyway, we don't have an plus 1, so we will not go for this one. Only check this one. This we got as false. That's why it exits out. Right? Out to this one. Now it again checks n plus 1. The latest I is n plus 1 is less than equal to n. True? False?
False, ma'am.
False. So will it execute this then part or not?
Which part, ma'am?
Then part. This. At here we have. I'm just saying we are at this one. N plus 1 is less than equal to n. So this false. So it will not be executed, right? So it comes to else. This gives you location 0. That means x is not present in the list. Understood? So whenever x is not equal to any of these integers, it gives you 0. Clear?
Yes, ma'am.
And then we did binary sets. Time over, actually.
Ma'am, can you continue tomorrow?
Yeah.
Okay, ma'am. Thank you, ma'am.
Now here I stop. Thanks all. Oh, you don't have any class right now.
We'll go to sleep.
Then we could continue, no? If you want to ask some particular doubt, then or else we can continue. Okay, stop. Thanks all.